Hi and welcome to this new video. In this video I'll try to show you how you can add joints that are controlled in Gazebo in ROS2. So this has changed quite a bit from ROS1 to ROS2, and I'll try to make it as easy as possible. So we will be working on the simulation that we used on the previous video. If you haven't seen it, just click it somewhere, it will appear. There I taught you how to create a differential drive robot as a box, and today we're going to create basically a car, so a car that moves around and can steer the wheels. Okay. I'll go more into details on the limitations of the car and so on, but basically that's what we are going to do. So first of all, I'm going to show you what we are going to do. So let me just put myself around here. So the first thing is I launched the simulation, so you have a better understanding of what we're talking about and what we want to do. So there we go. Okay, so I'll show you also how to add meshes in the Chakro as an extra, but basically this is what we have. So I borrowed this mesh from PICOCAD software. I'll leave the link in the video description. And basically it's a very simple car with 4 wheels, and it has a back drive, and then we have steering in the front. Yeah. So let's have a look how this is done, and then we'll see it in action. So first things first, we have to go to the code, and here I'm going to start from where we should start, which is the launch simulation. Okay, the launch file. So if we go here and we have boxbot launch, we basically have the same launch that we had in the previous video, which is we start a world and then we spawn the robot. Okay, so if we go to the spawn robot, which is this one, the version 4, we have several things that I'll go into detail. This is just something that I was working on, so don't it's not important here now. Essentially what I'm doing here is launching this spawn bot and then launching this robot state publisher. Okay, this will publish all the static transformations of the car in RViz, okay, not the joints. So here, well, it's the joints, but it's the fixed. So here we're going to, this is just spawning the robot, and this is the state. And as you can see, there's no control. So here I have it commented just because of issues of ROS2 that I haven't fixed yet. Then where is our control? So in ROS1 we loaded controllers and things like that, and we also loaded a YAM file for the config file, which we do have here. So we have here the position one, but where are we loading it? So the thing is that in ROS2 it has been changed to the Chakro file. So if we go to the Chakro here, we can see that we are loading the control file here. That's one thing. And then the other thing is, okay, then where are my transmissions and things like that? Well, we don't have any transmission systems now. So what we're doing is using this ROS2 control and this plugin, which is Gazebo ROS2 control. So it's very important that you download these 2 Gits, so ROS2 control and Gazebo ROS2 control. and you have to download them and compile them, because for example here I installed it from the Debian from Ubuntu, and it gave me some issues. So I highly recommend you that you download the source code and compile it with Qualcomm build. Okay, so how this works. So we define the joints that we want to control, which in my case it's the body steering wheel, steer right and the left. And we define some stuff like the limits, so the maximum value of the angle that we can turn it, and then the interface, which in this case we are defining all of them. Okay, then we go to the configuration file, which is this one, and we see that here we are joint trajectory and also the joint state broadcaster. And in the joint trajectory we are defining the joints, which are these two. If you had, for example, a robot hand, then you would have like 20 of them or 30 of them, okay? Then interface, we are using position. Why? Because we want to basically say I want to steer like 45 degrees or 30 degrees through speeds, through velocity. It's much more difficult to control because you would have to say 5 meters per second and then stop it, this kind of stuff. So position is perfect for this matter. But you can do it, and actually in the code here I have the controller for velocity, so I won't show it because it will mix things. Okay, so now we have defined our joints and we are using the control from Gazebo ROS2 controller. So that's it. So in theory that's enough to have a robot with as many joints as you want, controlled through position. So you could do a humanoid, you can do a quadruped, anything. In this case we are just doing a car. Okay, so once we have this, it's just a matter of loading the controllers. For that I have this this command that I've left here. We have to load the joint state broadcaster, and then we have to load the joint trajectory controller. These two controllers are the ones that we were defining here in the config file. So as you can see, the controller manager has two: joint trajectory, which is the one that controls all the joints, and then the joint state broadcaster, which broadcasts the value of the angle, which is very important to have first to control and then to have it in RViz. Okay, and that's it. So we open a terminal and then we load it. So I have it here already. Let me just copy paste it from here. There we go. It has to say successfully loaded controller, otherwise it can give you errors, and those errors normally mean that you install the Debian option, the apt sudo apt version, or you didn't source properly. Yeah. Then once we have it loaded, here we have some messages, which is loaded controller manager, blah blah blah, loaded controller joint state broadcaster, and loaded controller joint trajectory controller, and that's it. So if you have these messages, it's ready to work. So if we have a look at our fantastic super cool car, we now can execute this command, which is steering, and I'll show you what it does and how it works. So we go here we execute it. And there you go. So we moved the joints, both of them. So how does this work? Let me show you. Steering launch, okay? Oh, sorry. Steering launch. It's very simple script, which is the wheel steer, and as arguments I'm giving the angle that we want to turn. In this video I'm not going to show you how we are doing the algorithm for the steering. So we did a very simple steering. The two wheels steer the same, but we shouldn't do that in a car. So if you're interested in that, leave a comment in the video description and I'll do a video explaining how to do that, and we implement it in the simulation. So wheel steer. We go to wheel steer, which is here in scripts. And here we have an action client. So if we go here, so when we start the trajectory control, there's an action that is executed, and that action is the one that we use to send commands to the joints so they move in the correct way. This is a very good example of an action client in ROS2. So you have a very good example here. And essentially what we do is we start the goal, we put the names, we put the values, some other stuff that it needs to work, and then we wait for the action server, and then we send the goal. It's asynchronous, and then we have the callback. We add the callback, and we could print the feedback. So we have feedback and we have a result. So very, very good implementation, and it really works really well once you make it work. But at least it's very good for very slow movements. As you can see, it doesn't move very fast, but at least we have something working. And that's basically it. So you can see that if you do ROS2 action list, action list, as you can see in ROS2, we now have a way of listing actions. They are separated now. You have topics, services, and actions. And that's quite it. So as a bonus for the people that stayed until the end, just show you that how I loaded my meshes, because for some reason Gazebo, I wasn't setting it right, and I'm working on it still. But if you have the same issue, I just fix it by, for example, the body. I just fix it putting the absolute path to the mesh, and it worked like a charm. So it's really fast and you don't have to source anything. So I think for the moment I'll leave it like this. If someone has a suggestion of how to do it in a more robust way, leave it in the video description, in the comments below, sorry. And that's it. So thanks a lot for staying until the end. If you like the video, thumbs up, and subscribe if you haven't done yet. We upload videos every week about ROS related topics, especially now we are on fire with ROS2. And please check out some features, new features that we have added to ROS Development Studio. Like for example, this one, so robot connections for third parties, and you are able to connect to your own robot through web very easily. It's a feature that it's being uploaded right now. It will be available, if it's not now, then in a very close future. So check it out because it's really amazing. And that's it. Thanks, and see you in the next video. Peace.